Space clearly offers a unique vantage point from which to observe the impact of these events, and also to support the essential relief efforts. This topic is particularly relevant for IAC, in particular in Naples, which is a site where several disasters have happened in the past. Of course, the most well-known being volcanoes, with the Vesuvio and the Etna and the Stromboli, not so far, but also floods and so on. So Naples is definitely the place where we cannot avoid this topic. And in addition, of course, in Europe, with Europe being so much involved in the development of the chart and trying to help natural disasters resolution all over the world, I think it's a really appropriate topic. Our plenary event will be broken down in three elements. First, we'll have an overview of the contribution of space in disaster risk management, including in particular consideration and presentation of a range of sensors and missions that contribute to prevention, preparedness, response, including their use in the international charter that I just mentioned, this charter called Space and Major Disasters. And the second part of the plenary will be dedicated to the role of space in the context of international humanitarian community, how aid actors operate, how they need space assets, how they use it. And finally, the third part of our presentation will consider the post-crisis phase of disaster management with an important consideration of user needs, and trying to encompass, of course, tsunamis with Dr. Homa, but also other disasters. Let me tell you that after these presentations, we will have a session of question and answers, and our staff will go around with some small sheets of paper on which you can write your question and your affiliation and your name, and it will be collected, and then as a function of the numbers, some selection might be done or no selection at all, depending on the content. And our staff here, Jim Graff, Brent Smith, Simonetta Kelly, will look at that in advance of our consideration in the panel. We are privileged that our panel consists of an international group of specialists. Maurice Bourgeot, on my right, first right, head of Earth Observation Science, Applications and Future Technology at ESA. I will present them more in detail before their presentation. Francesco Pisano, manager of UNESAT at the United Nations Operational Satellite Application Program, and Masanori Homa, executive director of JAXA. So the topic of the session relates, of course, to the use of space science and technology for the mitigation of natural disasters, as well as the management. We'll have an opportunity to discuss both LEO and GEO satellites, so as much as you like. So let me now introduce Maurice Bourgeot. Maurice Bourgeot earned an engineering degree from EPFL in Lausanne, in Switzerland, had a Master of Science and a PhD from MIT in Electrical Engineering and Computer Science. He worked for DLR in Munich and was then a member of the staff at ESA, NESTEC, from 1989 to 2002, where he was responsible for several space technology and EO projects. From 2002 to 2004, he was with the Swiss Space Office, where he was a Swiss delegate at the ESA Program Board for Earth Observation, Satellite Navigation and Communication. And then between 2004 and 2010, he was director of the Space Center at EPFL in Lausanne, where he successfully led the university team which developed and built the Swiss CubeSat satellite. Between 2008 and 10, he was chairman of the ESA Program Board on Earth Observation, and now he's back since 2011 at ESA, where he's the head of the department dealing with science, application, and future technologies in the Earth Observation Directorate. Thank you very much, Maurice. You have the floor.
Thank you, Paul. Good afternoon. good afternoon to all of you. It's a great pleasure and also an honor to be here with my distinguished colleagues to discuss about this important topic here of how Earth observation can contribute to the disaster risk management. I'd like here also to take the opportunity to thank the co-organizers, not only Paul, but it's Brent Smith from NOAA, it's Simonetta Kelly from ESA, and it's also Jim Graf from JPL who organized this session. So let me, yes, okay, let me show you what's at ESA, what we do in terms of, disaster risk management and how we address, how we can use the Earth observation data. And I'm sure a similar chart could be presented by each of the space agencies around the table. Of course, we do operate satellites, EIS and VSAT and Sentinels are mentioned. Unfortunately, none of them are flying, and well, two of them, as you know, are not flying anymore, and Sentinels will fly, Sentinel-1 will fly next year. But very important for me, I insisted on these three names because with two of them you can look at the archive, and for disaster and risk management, it's very important to be able to compare before and after. Hence, all the data in the archive is of prime importance. Data continuity, so it's why I put Sentinel is a key point here. Now at ESA, we were together with CNES and the Canadian Space Agency, the co-founders of the International Charter on Space and Major Disaster. I'll come back to this, but it's a key element here, in the cycle of the disaster, which is playing a key role. Of course, we operate satellites and we distribute and we provide Earth observation data also from third-party missions here. We have the JAXA colleagues. As you know, ESA was responsible to distribute the ALOS data in Europe. ESA is not only about building satellites and hardware, but we also exploit the data, and we run several programs here like the GMS service element, value-added element, data user elements, which is really to push from the science towards the applications and also the downstream sectors to make sure that the Earth observation are used. And in this respect, of course, the use of Earth observation data for disaster is of prime importance. We are part of CEOS. CEOS is, also looking at disaster risk management, this DRM. There's an ad hoc group here that will show some of the results at the forthcoming CEOS plenary in a few weeks from now. We're also very involved in cooperation with the World Bank, with the so-called Global Facility for Disaster Reduction and Recovery here. And of course, on top of fostering activities for Earth observation, we also look at, as I said, the complete cycle from science toward application towards downstream sectors. And here, just an example here that I've seen, that I show here on the right is the what happened, fortunately, on the 11th of March in Tokyo. This was produced with ANVISAT. It's an program. You see the displacement and line of sight can go all the way to 2.5 meters here. But what was very innovative here is to combine different strips of ANVISAT data, like it's 100 kilometers wide here, so it's 3 strips, and then to have them of 800 kilometers, so to have a complete coverage here of the area north of in the northern part of Japan. Now, let's go to the next one. Okay, when you look at disaster risk management and what you can do, the first thing is, what are the users, like what do they want? And it's something which is not easy, and I'm sure most of the audience is aware, because you have different type of users in terms of disasters. Well, you have national governments, local authorities, municipalities. When an earthquake happens, you are really talking at that level. If it's a flood or like more hurricane, you are looking at a much larger type of community. And then it could be protection, civil protection agency, and a different kind of also of administration in a country or like in several countries. So really to identify the users is not easy. And similar to disaster risk management, we're also looking at climate change. We are at ESA Climate Change Initiative. And for us, it was much easier to discuss with the UN. There's something called the so-called Global Climate Observation System, GCOS, where they had like very clear requirements in terms of the essential climate variables, like, in sea surface temperature, like the precision, the accuracy that you can easily do with Earth observation data. Disaster is something much more difficult. So what we decided to do also is to contact, international groups and like what we call key stakeholders or champion users. And you have several related to the UN. You have the World Bank. You have something called the International Strategy for Disaster Reduction at the UN. So really, you have already quite a few organizations which are working with some disaster organization in order to get their user requirements. Of course, GEO and CEOS, the Committee on Earth Observation, I mentioned this. The science community, of course, is very interested in what can be done in terms of improving the relief in disasters. And, of course, mass media, journalists know this, because, when a disaster happens, of course, you have large coverage of media. And I've just shown here the famous wheel here of the disaster risk management. And here, if you want, of course, you have when the disaster happens here. Okay, and then this part is actually rather well covered with the charter. I'll come back to this. But you have all the other part here of a disaster, what we put in this wheel, like in terms of prevention here. Can we do some prevention in terms of disaster? And then also the post-disasters here. And of course, here you see, of course, as soon as a disaster happens, of course, the media is quite interested. So, but again, here what I would like to stress, up to now, Earth observation, especially using satellite, works very, very well in that part here of the wheel. And the whole idea is trying to extend, can we do more for the complete management cycle. Then, what can be done here? If I can move here. Now, I was talking about this part when the disaster happens here, and I will call this emergency response. We have the charter here, and this part is rather well covered. It's not only the charter at an international level. In Europe, you have also the GMS emergency service, which is started with SAFER, now it's called EMS. But you have also in Asia, you have something called Sentinel Asia, and I'm sure my colleague here from JAXA will talk about it later. So really, this part actually works rather well. Now, where we are trying to work here is in terms of preparation, in terms of prevention. And this part is much harder because, as I said, user requirements are maybe less easy to identify. Now, I told you about this, this necessity of the archives, to have data before and after, and it's where, I believe Earth observation has still a major role, by satellite, has still a major role to play. Now, all the phases here, of course, of the wheel that I showed, you can do also a lot with Earth observation data, and this has still to be covered and improved, DMs. But of course, DMs using interferometry, we have been going a long way since the first DM produced by satellites. But also in terms of land use, land cover, also to have this before and after could be extremely useful. And here again, showing the different cycles here of the events here. Just show here in the green what happens here in using the charter when data are used as observation data, and of course just after the disaster. And then in blue, it's more like what can be done, what we'd like to do more in terms of in using added values in order to identify, to help the agency which are on the ground here. Now, let me also spend a few words here about the first point here, because a key element there is the work of the International Charter for Space and Major Disaster. Now, this was created 10 years ago here, well, slightly more in 2000, as I said, by Isaac Ness and the CSA. It's been extremely successful, so as soon as you have a disaster here, you have like authorized user who can call, and then all the satellites from the different agencies are tasked, and then can image the region which has been detected. Then, so we have some examples here. This example here of what happened in Pakistan here. Worth noting here is since 2000, when the charter was created, we had more than something like 350 activations. Now, it's not uniform. In 2010, we had 50 activations, or 2011, we had 30 activations. But you know, we are talking of major disaster. Like for IT in 2010, we are talking of 200,000 people who unfortunately died. In Japan, it's something like 20,000 in 2011. So really, it's of key importance, and it's so important that at the Charter we have decided to open this, the so-called universal access. So you don't need to be a charter member, authorized users. If you are civil protection here in any country of the world, you can also raise the charter. So then, to conclude here, what I'd like to say here, like I show you this, the wheel here. I think in one case we're doing very well in terms of Earth observation, in terms of response and recovery. This works well. Where we still have quite a few things to do is really in the risk prevention and how to prepare, like can we prevent or things like that. In Europe, it works rather well. You have the Geo-Supersite initiative looking for volcanoes. We are looking with national civil protection in Italy or in Switzerland, where definitely Earth observation is used. But really also like in other parts of the world, really what we have to show is really to raise the awareness and to present the Earth observation maybe in a non-satellite centric integrated system in order to promote the use. And just to finish here, I have this video here of the 2010, the earthquake in Haiti, where, as I said, more than 200,000 people unfortunately died, and then to show some examples here of what could be done with Earth observation, extremely useful to some of the users. And here there's an interview here of the French civil protection, but where basically all the interest of Earth observation data can be put, to the use, to the benefit of the users. And you have different, on the maps you can see in green and red here, the different areas here that can be, red I believe is the emergency hospital, blue is where you have water, green where you have some headquarters for the police, for the civil agency. So really using this data, you are helping them very much. With that, thank you very much.
Thanks a lot, Maurice. So we'll keep the questions for the question and answer session. I recall, by the way, that for the press, there will be the opportunity to interview the speakers after the session. So for the press, there will be a privileged moment for questions. Let me present now Francesco Pisano. He's an expert in international affairs and geopolitics with a professional background in humanitarian affairs and risk management. He studied international relations with a specialization in conflict resolution and law with a specialization in international and constitutional law. He joined the UN in 1993, where he took positions of increasing responsibility with the Department of Humanitarian Affairs, in particular the Division for Disaster Mitigation, then with OCHA as senior officer. He now serves at the UN Institute for Training and Research, called UNITAR, where he is the manager of UNOSAT, Operational Satellite Applications Program. Before joining the UN, his previous professional position included business development with a multinational company and international development cooperation with Italy's Foreign Office. So, Francesco, you have the floor.
Better now? Okay. Thank you. First of all, I want to thank you all for having walked into this room to listen to us, and the organizers and the European Space Agency for involving us. I think this is the best slide of this session, is this one. The UN between two space agencies. And you don't? Okay, let me, I don't want to break anything here. Okay. I was saying that this is perhaps the best shot to take on from this session is this visual of the UN between two space agencies. It's a way to show that we can work together. Thank you. Maybe this is better. That we can work together in practice, and this is what I would like to do for the next 10 minutes or so: is to deorbit you from space to down to the ground and show you what we do. In terms of using this technology. Okay. I want to show you, first of all, I was called here to talk about response and how we use satellite technology in response, but I at least owe you clarity on what we are. We are an operational program of the UN. Operational means that we don't do conferencing and resolutions, we actually do operations, we only do operations. In these three areas that you see behind me, only a portion of that, more or less 30%, 35% of what we do relates to disasters. The rest is very more relevant to human security, human rights, the violation of international humanitarian law during conflicts, and territorial planning, which is really the rising star. Any territorial planning, it is also included what we're talking about in terms of disaster management, etc. And I do agree fully that the potential of satellites in that area, pre-disaster, is enormous and largely unexplored. I'm showing you this very rapidly, this one and this one. And why am I showing you this? Because the times where mapping using satellites was a special effect, a groundbreaking novelty, are gone. Okay? This is now a standard, serious business with users and beneficiaries at the center, and we all collectively, in the space segment and down, the analysts like us, hold a collective responsibility. This is no longer about, stunning audiences with the latest interferometry application, etc. Look what science can do. We have generated over the years and before GMES expectations, practical applications. What you see on the left of this slide is what the UN is currently doing using this technology. Not planning, not talking about, doing. So the first message is this, that we hold responsibility in the professional domains that are scattered through this technology, to these applications. And the users now ask pertinent questions. They're not an indistinct flock of people that one can use to leverage his or her own project. These people use it and therefore have something to say, and it would be a terrible failure if we fail to listen to them. Another interesting piece of fact that I want to show you is what we do during the year at UNOSAT. We have been triggered or activated, as we say, since we started humanitarian mapping service for the humanitarian community back in 2003, some 300 times. What you see is a consolidated 2 years view. That tells you a couple of things. First of all, it tells you that 40% of this activation relate to disasters that have hydrometeorological components in them. So basically the world is prey to water, storms, tsunamis, etc. is well above 40%. The other fact is that we use this technology in roughly 40% of cases in conflict. Is what you see there, we call in the UN complex emergencies, meaning, IDP crisis, refugee crisis in conflict, etc. So Syria for us is a complex emergency. And so that disasters are important, but they're part of a continuum that includes other crises. So we talk about disaster and other crises. So crisis response. First of all, I have to say thank you to our friends in the space business, because not only they listen to us, not only they help us. The Charter is a brilliant example of how a best effort-based idea can actually change the world of people like us that run analysis and the beneficiaries. You call them users. They're not your users. I'm your user because I use your data. The beneficiary at the end of the line uses an elaborated product that gives him information. At that point, he doesn't care whether it's coming from satellite or a drone. Actually, we use drones since last year, and we use them in Haiti as well. What he cares about is a couple of things that I'm going to show you very fast, very quickly. Situational awareness. Now, this is something that we do a lot. It's an expanding market. What it is basically the first question that people put on the table. What, where, how big, how does it behave? You see that here, even in this example of this flood here, there is a mesh between moderate resolution and very high resolution on the right. And this is something that we do a lot, that the users use a lot in the field and headquarters. It is, however, very remote from the quest of the perfect map that we see in research centers, in academia, and also in space agencies. Users don't look for the perfect map. And I don't want to mean rain on the party, but there's no perfect map, because it changes over hours. And during these hours, what is clear to us from the practice point of view is that a peak of contribution from Earth observation comes in the assessment and analysis, is where space provides the other slice of the sandwich, the other one being the information from the ground. Okay? And these two forms a sandwich that does what? Enhances the analytical capacity of those who have to take action. What you see behind me is not a natural disaster. It's actually ethnic-based, an ethnic-based crisis in Kyrgyzstan. Is actually the how should I call it, unrest in Osh that provoked several deaths and a lot of arson. This is a job that we did at the request of the High Commissioner for Human Rights, for refugees, High Commissioner for Refugees. What was the question there? It was, what's going on? Where it is going on? What does it look like? Well, to us, it looked like ethnic cleansing, because by superposing GIS layers to the actual satellite analysis, we discovered that there was a pattern in the way in the house burned, and this house were all in the Uzbek minority inhabited area of the city. We cut short by weeks a process that would have taken weeks to the UN. We flew to this place, the High Commissioner for Refugees himself, with these maps, and they knew where to go. So we contributed an essential piece of information. And this is what the little miracle of this application is mostly in there. There are other places. Another place is this, decision-making support. Why I was insisting so much that this is not a groundbreaking special effect anymore. Because what we're trying to do now is to see how established work processes in the user community can actually integrate this to make better decisions or faster decisions or decisions that hold with time. What you see behind me is an example that is very dear to me, because it's the first time in the history of humanitarian affairs that an entire assessment of the destruction by earthquake was operated from space in 14 working days, including weekends. An exercise like that takes the UN between 2 and 3 months. During these 3 months, we continue to reissue updates of what we call flash appeals, meaning how much money we need to spend in this place to do a number of things. When you hear humanitarian, you hear a lot of things in there. The hardcore life-saving humanitarian phase never exceeds 2 weeks. So there is more in humanitarian action that actually meets the eye or hits the press. And one of the essential parts of that process is the damage assessment. Damage assessment is conducted by people walking in the street, with pieces of paper and pens that turns into Excels, etc. We're introducing this kind of technology. We introduce drones, we introduce mobile applications, and this will lead to real-time mapping on the fly, web-based. Someone can say there's not enough internet connectivity in the field. I will deny that. I think that today we have connectivities everywhere, one way or the other. So once that is done in the field, once the applications are mature, then the decision-making processes can rely on this. And the moment they rely on that, we need to feel that responsibility, and we need to work together to fulfill it. So where is the forefront? I think the forefront is less in space today and more in what space can change in the way layers of knowledge and actors interconnect. So I won't go into that because it takes, I would exceed my time that is running out right now. But we are not experimenting, we're using this. We're using collaborative mapping, we're using social media, and we are using the power of the objectivity of Earth observation to offer a backdrop, a platform for this information to come together. What you see here is a very basic example that we started years ago, and when we started it was quite stunning. Crowdsourcing in its most useful application, which is background data, in my opinion, merged together with expert analysis, that maybe is less for crowds and more for specialists, contributed to shorten the time and roll out more accurate products in rapid series. And we were able to feed this information, this data back to the disaster risk reduction process. And my colleague from ESA was talking about that. And so I will conclude here. What you see behind me is there are applications that you can use to get in touch with us. It's important for us. We're the UN, but we work for all. We work with everyone. So join in. Let's work together. Thank you for having me here, and I look forward to your questions. Thank you.
Thanks a lot, Francisco, again. Let me now introduce our third speaker, Mr. Masanori Homa. He entered NASDA in 1977. He was working on the geostationary meteorological satellite project. Then he went to US in charge of the Los Angeles office. Then he came back to Japan at the Tsukuba Space Center, and he held several positions, technical, management, international affairs, policy, external relations. He then became Director of Program Management and Integration Department in the Office of Space Application of JAXA. Then Director of Application Program at the Office of Space Application, and in 2009 became the Executive Director for Space Application Mission, Spectrum Management, Space Tracking and Data Acquisition, as well as environmental test technology. He's now the Executive Director of JAXA, the Japan Aerospace Exploration Agency. So the floor is you, Dr. Homa.
Thank you, and good afternoon. First, I will explain about our disaster management activities by use of the actual scheme, so-called Sentinel Asia. This scheme was working for last 4 or 5 years under the concept of collaboration between space agencies and disaster management agencies. This concept is very comprehensive. However, please look at first the end user. End user is absolutely the importance for disaster management. So every country has disaster management organizations, and generally two layers. One is central government organizations and local government organizations. Generally speaking, police or fire work or such kind of worker is belong to local government organizations, and military rescue is belong to central government organizations. That is our concept. What does disaster management organizations conduct in the case? Considering these so-called utilization organizations, from the viewpoint of space agency, please left-hand side, space agency can take the many observation data by use of satellites, and as you know, once the disaster happened, disaster information on the ground is a lot of information we can get. So, the most important things at the time of disaster happens, combining two kind of satellite data and inside institute data, ground measured data, that make a value-added information. So, the transmit of this information is another items to be considered. In the case of earthquake in Japan in last year, every communication links on the ground are stopped. There is no way to communicate between central government to the place where the tsunami attacked. So, some communication satellite has such capability to support when ground communication networks does not work. And in another way, internet is a very robust information system in the case of disasters. So, this chart shows two kinds of communication links. And as you know, the training or capacity building is very important. So, we JAXA conducted the disaster management training with local government 5 or 6 times a year to simulate the real disaster happens. That is our disaster management concept. This chart shows the actual satellite observation data when the earthquake attacked in Japan last year. Before the earthquake taken by Daiichi on December 4th, 2008. And the another chart shows 3 days after the earthquake taken by TEOS on March 14th, 3 days after the earthquake and the tsunami attacked. TEOS is a satellite in Thailand. You can see very clearly how much area are covered by tsunami. This dark area is covered by seawater caused by tsunami. From this kind of data, we can overview how much the disaster is wide and serious. And by the help of International Disaster Charter, many countries and space agencies very kindly transmit their observation data to Japan. Totally, over 5,000 scenes are provided to Japan, both from space agencies and private sectors. We have very much data from satellite, and this is very helpful. By use of those data, we have some we found some issues which I can say lesson learned. Please imagine when Earth observation satellite fly on the special point. For optical observation satellite, many satellites fly on 10:30 or 1:30 p.m. So we had a lot of data, but the observation time is almost the same time. For instance, the earthquake attacked 2 o'clock and 40 p.m. So there is no optical observation satellite data to the next day's 10:30. So from the viewpoint of the considered or to analyze the disaster effects, the time scale is very important, especially in the fast quick response is required. In Japan, once a severe disaster happens, government gathers experts within 1 hour, and Prime Minister and the related minister should gather within 3 hours. So 3 hours is a kind of magic number as a quick response. Many data should be provided within 3 hours, after 3 hours. So if in the case of Japanese earthquake case, no satellite data was given by optical observations. So, and from the viewpoint of space agencies or planning satellite programs, please let's consider the local sun time is very important for the case of disaster management. I should say the another example for synthetic aperture radar. Many such kind of radar fly on dawn dusk. So observation time is 6 a.m. or 6 p.m. That is our lessons learned. And we have another items, so-called lesson learned, but I skip it. Next issue is how to react to pre and post disasters. This is a common interest of all of our panelists. And this cycle of disaster prevention is very familiar to you, I believe. So emergency response is what I explained just before. And recovery or mitigation or preparedness is the next very important issues. So I just show you the two kind of examples for the recovery or such. Okay. This is a GNSS monitoring for called GPS receiver geoinformation systems. And after the great earthquake, the land moves. For instance, in Japan, almost 10 meters moved. So, for the recovery planning, the positioning is very important. However, we lost the standard positioning systems by ground thread. So, almost 1 year later from the earthquake, the movement of the ground is stopped. So, at the time, another agency began to readjust to set the ground point standard networks. That is very helpful by use of navigation satellite system. This is the last chart of my presentation. Tsunami makes a lot of debris on the sea. So, such kind of debris moved onto the tide or wind, sea winds. So, Japanese government simulated to how to move such kind of debris towards the Pacific Ocean. This chart shows us example. So, based on simulation, in near future, many debris will reach to the west coast of the United States. I'm sorry, but that is our simulations. So, by this evaluation, we can take some kind of countermeasure or to inform the United States and Canada to please repair. Okay, that is my presentation. Thank you.
Thanks a lot, Dr. Homa, for this very appropriate and with a lot of, I would say, concerned areas over the world. I would like now to go to the question and answer session. We were getting quite a lot of questions. We have been trying to summarize them into a few sets because we have only 10 minutes. So let me ask to Maurice Bourgeot a question which has been expressed in one form or another by several people. This question is as follows: What space measurements are missing today from the existing capability, from the type of user you got, user feedback you got, and in particular there was an aspect also related to prediction of earthquake, whether there is any possibility to predict. But globally speaking, what are the sensors which are missing today as you see it at ISA?
Okay, thanks, Paul. Well, of course, coming from a space agency, we'll be interested in having even more sensors here. But there's, of course, a question of cost and benefit here. Is it worth it? And I'd like just to start answering this question, like in 2011, it's three figures, but it's easy to remember. It's like because of disasters, 300,000 people died. This was in 2010 because of the IT. It's more than 200 million people affected here, and it's more than 200 billions of damage. So every time you just multiply by 1,000. So those are amazing figures. In terms of really what in terms of instruments or things that you need for the charter here, the example of the charter here, I think for one part of the cycle that I showed earlier, I think we are pretty much well covered, but it's only a small part. We don't do any prevention, we don't do any risk assessment or things like that, or recovery afterwards. But even though you heard what Dr. Homa said, that even in the case with the existing satellites, sometimes, data delivery, you would like to get the data as soon as possible. In average, for the charter, you get the data like approximately 1 day, 1.5 days after the event. And Dr. Homa said, and I'm sure many civil protection agencies will say, you need the data with a shorter delivery time. So maybe it's one direction to go. In terms of type of sensor, again, for the charter, like in 2011, we use approximately 1,000 scenes optical sensors, so Landsat types, medium type of resolution. We use approximately 500 SAR scenes, so either from RadarSat, from TerraSat, from Anvisat. But we used more than 15,000, so a much higher number in terms of high resolution, very high resolution, so the world view. So really this type of course of satellites are needed in order to do the assessment just after the crisis, because you have the high resolution. But in order to cover the whole circle, what we should do in the future here, you need also more data, more often, so there is a data gap. But you don't need very high resolution. We do this in the frame of the earthquake and volcano question was raised. We do this in the frame of the geo-supersite hazards, where we monitor all type of volcanoes here around the Earth on a continuous basis, using basically radar images to look using permanent scatters or soil interferometry techniques in order to monitor and see what happens. So it's not always high resolution, but it goes in several types of domains in order to have all type of Earth observation data. Thank you.
Thanks a lot, Maurice. Francesco, you can take your pen and your paper. I'm going to ask you 3 questions which are all related to the same main topic, so if you can synthesize the aspects. One look at the question is what is the weak link, the critical link in the overall operational chain, which limits the efficiency of your action. Another question, which is looking at another side, is UNOSAT seems to be very successful in delivering information for humanitarian aid. Are there any technological breakthrough that you are awaiting for that can help you to do your job better? What do you expect in particular from Space Agency in the future? Another look at the question is why the international charter has been activated until now only in the response phase and not in the prevention phase to identify the possible disaster before it hits. And the last angle to look at the question of operational view from you is disaster management often is locally centered with managers unfamiliar with space-derived information system. Has any attempt been made to develop templates of space information that can be made available at short notice and to train local disaster managers in their application? Chair.
Well, in the interest of time, I'll try to really be short, and forgive me if it's not very, very clear. I'm not trying to not answer the question. The first thing, what is the weak link? I don't know what's the weak link. I can tell you what is the missing link. The missing link in the job that we're doing is the very old system that rules and governs licensing in the commercial business that the satellite data is. It's old, it's ineffective, it's expensive. It's a discouragement to people like us. It needs to change. The way we allow technology to escalate in the minds of people for the greater good does not correspond to the way we sign contracts, authorize or not authorize people to share data, and authorize or not authorize even the UN to pass on data. Apart from vector data, you're looking at a person that has shared everything we have analyzed since June 2000. Now, find me another example like that, we're ready to on the cloud. So I think that is the missing link, not the weak link. And so we give a lot of money to commercials, we are friends with them, we depend on them, we would like to see them, asking the question, how can we make even more money and make your life easier? I'm talking about the commercial. The space agency is different in this case. Okay. So what's next? I think what's next, what is groundbreaking, it's sharing. It is sharing. It's an entropic system in which everything is available somewhere at some given time. We're beyond the portal, gentlemen and ladies. We're beyond this myth of the portal. We are in fluidity of information. And for me, the next thing is the Twitter of satellite data. It's everywhere at the same time, and then you need to operate the intelligence, here, not intelligence of the army, to go and fetch. And that will be, if you look at ArcGIS 10, what it does is basically a system that allows you to do maps on the fly, and maps are virtual. They're like a Google search. That map that is for you right now, it's your search. You can crystallize it and send it to someone else and add on it, or it can disappear, just like a Google search. That is the future, in my modest opinion. Why the charter, not before? Well, because I'm not a legitimate representative of the charter here. I shouldn't be answering that. But in my practice, the charter is a best effort basis. It's a very useful tool to people like us. And it was created like that. It was created for major disasters. Now, you cannot have a major disaster before it happens. There have been cases in which, like I remember the Pacific, for instance, storm surges. You can tell it's going to happen, right? But the charter has a difficulty in meeting that. And I think it would be unfair to ask them that, because as a person that I admire a lot in the European Space Agency, Stephen Briggs, said, this is about making a difference. When the charter does not make a difference, we should keep it in store. We should save that. So where the charter makes a difference, I can tell you it's a big difference. And so I would prefer that our colleagues there continue to make that difference and start to go in more directions. One other question that has not emerged today, but emerges very often, is why the charter only for disasters and not for refugees, not for Syria, for things like that? So I think the charter is doing a great job of what they do. Local authorities, yes, this is very true. That is, the local disaster response organizations in many countries are those who make the difference. Those who are in the forefront, they know, etc. I think the question is, the question is a little bit on a false problem. It's not, you cannot ask a head of a local civil protection to become, an expert in Earth observation. You have to make your Earth observation digestible to them. You have to, avoiding the technical issue, you have to say, here it is. How does it fit in your process? How does it fit in your shop? Does it make sense? Doesn't, etc. So that is the true value of what we all trying to do in the space segment, which is basically user-driven. Listen to them.
Thanks a lot, Francesco. So one last question to Dr. Homa. From your experience in the Great Japanese Tsunami, what type of space system and space data do you deem essential to quickly put in place to improve post-crisis management of similar events? In particular, what improvements are needed to improve the response time? And where should space agency put their resources to improve disaster response?
Well, so based on our experience, space system is very, very useful for the severe disasters. And one thing I should say is the satellite or space system is very, very robust in disaster on the ground. However, the ground system is not so robust. So, in the case of loss of ground segment of, so for instance, data analysis node or such kind of ground segment was lost, and we need the new kind of robust grant systems based on international collaborations. That is the next our aim toward further international disaster charter or another future our conduct. Thank you.
Okay, thank you very much, Dr. Homa. So we are going to wrap up this session. We are about in time. I understand this last word about robustness. In particular, one aspect of robustness is indeed to have the right ground segment to be robust, but also as we gather data continuity, which is part of the robustness and which is bringing us back to, in particular, GMES and the importance of this program for Europe and the rest of the world. So thank you very much to everybody for participating, and have a good Congress. Thanks a lot. Bye.